You sing? Can you wave hi? Is this your favorite song? Oh, I love you so much. Oh, can you say hi? We're about ready to have a study session. I thought she might sing for y'all. She was asking for Frozen. Yeah. All right. Hey, y'all, what's going down? I'm going to pause this song. And what we're going to do is if you could take out your review and, hey, could I get a hug as you go to night-night? I love you so very much.
What's the song?
Yo, the song? Oh, we're going to pause the song because we got a study session tonight. Hey, Precal12, I hope you're having a good night tonight. We are going to get our review session underway. Sorry, it's starting a little bit later. We just came from basketball practice, so it's been a day, but we're going to continue it because I want to help y'all and be there for any questions you may have. So just a couple of things to remember. If you have any questions, please make sure you put them on the right-hand side over by the comment section, or you could also text me if you need to, if you have any questions as well on that end, and we'll get it going, okay? I'd like to get started with this study session. I'd like to keep it around 45 minutes. We've hit on a lot of stuff in class, but I recognize that there are some questions still to be had, and we're looking for two types of questions. Number one, specific questions off the review, but then also probably even more than that is the concepts that are addressed on the study session. And so I want to make sure that we address those in the best way we possibly can. So if you could take out those review set sheets, and we're going to get started with this review session here. And I'm going to simply pull this over. I'm going to share my screen. And seniors, I hope you had a good time off today. I know there were a couple juniors in my class who still had PSAT, but I hope that I hope you had a good time off, and hope you got maybe some work done, some time to sleep in, and to get started back within our week today. So let's get that rolling. I'm trying to think of the one that I believe there was one question that some individuals wanted me to do, and for some reason it's evading my mind a little bit here. So if you remember what problem that was, or if you wanted to bring that up, feel free. I'm going to get I've got the tablet all in, and that's all ready and set to go here. I'm going to pull up this YouTube video because I want to rock and roll off this. Let me see the comment section. Perfect. Yes, Rosemary, I love the tunes too. I'm a big Frozen fan. I gotta admit, big Frozen fan there. I guess you got to be when you've got a 2-year-old daughter. Otherwise, you'll drive yourself insane the amount of times you watched it. Okay, so let's go through them. I'm going to start backwards and kind of move forwards as you're kind of dissecting which problems you need to go through. Actually, hold up. Devin's got the first question, and I love it. Devin, I appreciate this one. I believe you had a question about this one in class, and I either forgot or something, and so I apologize. But this is a really good one, so let's make sure we address it and go through it together. It's number 12 on your review, and it's one where we are solving. And a couple things to remember when we solve. When we verify, such as the ones from numbers, I believe it was 2 to 11, we freeze one side, usually the right side, although you could do the left side. And we match the left side to the right side by freezing that right side. It's like a proof. But with this one, number 12, it's quite different. We're looking at trying to solve for x, really solve for the equation. Sorry, this should be 3 sine squared of x. And in solving, we always are looking at doing one common theme. We're not freezing a side. What we're looking at doing is trying to bring one side over to the other. So it would be as if I'd be subtracting 3 sine squared of x, and we would be left with 0. And then on the left side, we'd be left with cosine squared of x minus 3 sine squared of x. Now, in any solving problem, once I've gotten everything to one side, I can use different strategies to be able to solve these specific equations. For instance, in number 13 and 14, it's more of a basic type of problem that we're trying to look at because we're simply solving for the missing link of tangent. And there's no other identity there that we have to deal with. Whereas with this one, there's going to be one very similar to this on the review, by the way. I'm looking at trying to match up the cosine squared to the sine squared, or the sine squared to the cosine squared, either one. So we're looking at what Pythagorean identity could I substitute in for cosine squared that may speak the same language as this -3 sine squared. And what we can do is say, all right, 1 minus sine squared of x, which is what I plug in for cosine squared up above, and then minus 3 sine squared of x. And then once I simplify, I'm left with 1 minus 4 sine squared of x equals 0. So I subtract 1, divide by -4, and I'm left with, I'm putting this line down just so you can kind of see it, I'm left with sine squared of x is equal to positive 1 over 4. Well, I'll square root one side, give some love to that right side too, and now I'm left with square root of 1 over square root of 4, which is simply 1/2. So really it's, and by the way, when I square root a squared, make sure you have your plus or minus. We're looking for where sine of x is equal to plus or minus 1/2. Now we got to go to the unit circle, which you'll have tomorrow. And on that unit circle, we're asking the question, what? In fact, right now, let's play, we'll do a little Dora the Explorer. I want you to yell at the screen, what is, where is sine 1/2 or -1/2? Go. I can't hear you. Okay, I'm hearing a couple of you. Very nice. If you just yelled in your house, congratulations. You get the full experience of the podcast. And when we look at this, sorry, y'all. I get crazier as the night goes on, so I apologize. I end up getting all of the values that are over 6, and so that's why these are my answers. When I look at the fact that it's between the interval of 0 and 2 pi, you actually do not have to add 2 pi in because all of these are within the range. Gucci, we are Gucci. We are good to go, and we are for real, for real. Fur, I think is what you say. We are good to go. David's in the house. Hey, what's up, David? Devin's in the house, and Rosemary. Thanks for showing up, y'all. And David, I'm sorry, dude. I know it's been a long day, man. I feel you. Perfect. Okay. I understand, Rosemary. Awesome. I'm seeing this. All right, very good. A lot of these are just kills. Okay, so y'all are just doing this, but we're gonna continue with some problems, and we'll keep finessing, and moving forward. So if you got other questions out there, throw them out. Let's keep going. I want to go kind of backwards here. Starting with number 20 or 39 and 40. This was one that I felt as though we just needed another rep on, because when I think of the last year's test, this was one problem that was kind of a hindrance, or just kind of was a little bit tricky. So let's take a look at it. So first thing we know is that sine of u and cosine of v are the following two, right? Number 40, I'll do later on, or at least address. But with number 39, we know the formula. Stated off the formula sheet was cosine u, cosine v, minus sine u and sine of v. All right. Now, once I've stated the formula, what it's equal to, I simply plug in what I've been given. So 5 over 13 will go in for sine of u, and -3/5 will go for cosine of v. The problem with this is we don't know sine of v and cosine u, because u and v are two separate triangles. So in order to find this, we're going to set this bad boy up where both are in quadrant 2. Both u and v are in quadrant 2. So we're going to go over yonder over here. Okay, so we'll make this v, and we'll make this u. And so both of them are over here. Awesome. If you hear my daughter, my apologies. All right, we set it up. Okay, so the u, sine of u, is 5 over 13. So that would be the opposite over the hypotenuse. Perfect. Over at V, this is -3/5. So this is, and it's cosine. So it's adjacent, which would be -3, over hypotenuse, which is 5. So the question is what are the missing side lengths? Which would be here, and which would also be here. And to do this, we could just put x in, and we could just do our formula of x squared plus 5 squared equals 13 squared. So we have x squared plus 25 equals 169. And we end up getting x is equal to plus or minus 12. In this case, it's -12 because it's going to the left, to the left. Everything bound to the house to the left. In the closet, just don't stop. And dun, 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 dun. You must not know it. Sorry. I just did that, didn't I? I am live on a podcast right now. And I just did that. This is good. And we might just make songs up today. I hope that's okay. And if you're in any sort of theater, David, or anyone else that's watching, all I ask is just don't be jealous of my voice. That's it. Just do not be jealous of my voice. And as I've rambled on, what I've just done, and many of you already know the 3, 4, 5, but I just completed, did the Pythagorean theorem with the x over on the v side compared to the u. And so remember that v and u are just two separate triangles. The key is to find all 3 sides, okay? And again, x goes up in the air, okay? And there we are. So when we look at sine of v, okay, sine of v, we look at what is the opposite over the hypotenuse. When we do opposite over hypotenuse, that would be 4 out of 5. And when we do cosine of u over here, that would be the adjacent, -12, over the hypotenuse, which would be 13. And so then we got to multiply. We got to do a little PEMDAS, my son's name there. And when we do -12 times -3, we get 36. When we do 13 times 5, we get 65. 5 times 4 is 20. And 13 times 5 is 65. And so when I subtract this, I get 16 out of 65. And we are G to G, good to go. And that would be the answer there. Now, number 40 is exactly the same triangle, so don't have to actually solve for any other triangles. It's just a different formula. So when you plug in, it'd be sine of v cosine of u minus cosine u sine of v. Just be sure to follow the formula. And then we would just plug in the values that I have been given, and then also the 2 that I knew. Plug it in the same way. You'll just get just a little bit of a different answer there when you solve on that specific problem. Okay. Very good. Very nice. Yes, we are finessing. Can we do a factoring one? Yeah, that'd be good. We need to stop. Let's do the factoring one here. Devin, tangent of x equals -1 is on the unit circle. That was just a quick question before I get to David's there. If you look at a unit circle like this, if I look at 3 pi over 4, this is negative square roots of 2 over 2, comma, square roots of 2 over 2. So if I did y over x, that would be square roots of 2 over 2 over negative square roots of 2 over 2. Since it's the same thing, we can just cancel, and this would be equal to -1. So just as a heads up, -1 would actually be here. Cool. And so I think it would be here and over here. Okay. All right. Good. Good. Okay. Okay, got that one. Yeah, so David, great question. You'll have a unit circle for the test. You will also have every formula that you would need for the test. Big thing is just to make sure that you know how to apply it. A lot of application, showing the work, that's the key there. And David, I haven't forgotten about the factoring one. I'm just making sure if there's any other questions. Sing Coach Shay, you need to go on The Voice. I have always been told that. Hold up, Coach Jay, you need to learn to dance. I'm very offended by that because I think I'm a good dancer. I think that I'm a little raw. People have called me a little raw. But they've said that with a little bit of some work, a little bit of Bruno Mars, Michael Jackson kind of esque. It's kind of what I've been told, but just saying. Yeah, so when do we use 2 pi n? And then I'm going to actually go to David's question. Sorry, David. We use 2 pi n going back here. Whenever I say between 0 and 2 pi, you do not need 2 pi n. Same thing here. But when I just say solve the equation, or on these ones, solve the equation, solve the equation, solve the equation. In all of these, we want to make sure we add 2 pi n to it. Okay, in all of those. Cool. Awesome. All right, so I want to talk about 15, 17. A lot of these are related, and that's why. 18 is good. I want to go over 1, 2, and this is really just in case. I'll put it on the bottom here, and we could always come back to 19, but I'm going to put it below 19. 2 sine squared x plus 3 sine x plus 1 equals 0 when I say solve. We could actually solve for this one, and we'll look at these 4. All of these, David, are related to factoring. I'll understand these are solving the equations, but I think that there's a couple like, hold up, I actually said not to do that one, but there's a couple here like number 6, that's a factoring one. But ones that are similar to 6, where we'd have to actually factor. But I will tell you that all of the solving ones that I'm about ready to do incorporate the same thing. It would just be on the verifying side. So remember, verifying, we freeze a side, we match one side up to the other, right? And with solving, we take one side, take it to the other side, okay? And that's how we roll. So in this example, we're going to subtract square roots of 3 and add sine of x to both sides. So we got, if I did that, right, so this would cancel, and I would just do it to the other side. So it would literally be right here. So what I would have left over, I apologize for the room, I'm going to just put it below this line, and that just means that, not I'm dividing, this does not mean that. It just means that everything is put on the left side as negative square roots of 3 plus sine equals 0. And so if I simplified this, I would actually just add these up to get negative square roots of 3 plus 2 sine of x equals 0. Now, the reason why I wanted to show this to you, David, I could come back to it. You'll see that there's 2 trig identities, but I can't take out a sign because the negative square roots of 3 does not have a sign. So I just simply add like terms. And then I could add square roots of 3, divide by 2, and then find where sine is positive square roots of 3 over 2 on my unit circle. Whereas number 17, a little bit different here. I'm going to subtract cosine of x to the left side. Again, I get everything to one side when I solve the equation. So I get cosine to the third of x minus cosine of x equals 0. And so I asked the question, can I combine like terms? I can't, because they are not alike, like the cubed and one that's just to the first power, okay? You can't actually combine. So we then say, since there's only 2 terms, both have a cosine, I take a cosine out, leaving me with cosine squared in the first one. And be careful now, friends, be careful, friends. We've got to make sure that this cosine of x has a -1 spotted up there, okay? All right, so then we set both equal to 0. So we have cosine of x equals 0. And cosine squared of x minus 1 equals 0. And then I simply solve, and I say, where's cosine of x? 0. Right now, I want you to yell it out as loud as you can, unless you're eating Cheez-Its. What would that be? And you would be exactly right, frenzies. It would be pi over 2 and 3 pi over 2. And in both of these instances, I will add 2 pi n because it is solving for the whole equation, right? Over here, I would add 1, okay? And then I'd get cosine squared of x equals 1, square root both sides, and I'm left with cosine of x equals plus or minus 1. Where's cosine plus or minus 1? I'll put it over on the side here, and that would be 0. in pi, and then I would just simply add 2 pi n in order to get all of the answers to infinity and beyond, okay? I hope this is okay for y'all right now. Hopefully we're moving forward. I'm sure there's a song for that too, but I'll think on that one. You know what? Just as a quick thing before we get to the next few problems here, do you know what my favorite song is? One of them. Do you ever remember that Call Me Maybe song? I love that song. I really do. Something about it. It's just something about it there. I don't know why I said that, but I think that I just admitted something I probably shouldn't have, but that's okay. It is a podcast, and so if you're in here, that was a bonus for you. Bonus for you there. Okay, solve the equation. Again, we're going to bring it both to one side. I'm going to bring all that stuff over here, but just to show you that I'm going to bring that cosecant of x, that 2 cosecant of x to the other side. Take me to the other side. I think that's a song. I think that's Jason Derulo, I think. Okay, so we bring everything to the left side. Again, we look and see, can I combine like terms? No, because this secant and cosecant cannot be combined with just a cosecant. So we say, okay, out of the two terms, is there something in common? There is, in fact, something in common. So I could pull out a cosecant of x. And then I say, what's left over? Well, then I see that an SEC is left over, like they'll be left out of the college football playoff. Sorry, y'all. I'm crazy tonight. It probably makes no sense, so I apologize. I then look at the second one and I say, what's left over? A -2. Then I set it equal to 0 here. And then since it's already factored again, we set both of these equal to 0, and then we solve. So we say, okay, cosecant of x equals 0, and secant of x -2 equals 0. Okay? So I'm going to add 2 to both sides here, giving me secant of x is equal to 2. But I don't like secant. I don't know what it is, maybe because I don't like the SEC. And what I could do is if I flip secant, I would get the reciprocal, which is cosine. And if I flip 2, I would get 1/2. So the question is where is cosine? Positive 1/2. And I think it's in quadrant 1 and 4. And I believe that is pi over 3 plus 2 pi n. And 5 pi over 3 plus 2 pi n. So I got that one as that answer. Let's look at cosecant of x. Again, I flip this to get sine of x equals, and I flip this. This is going to be 1 over 0, or it's really where is sine undefined, because 1 over 0 if I flipped it. So when I look at this, there's actually no places. There's no places where sine would be undefined. So actually, we would say that the only answers would be these two right here for this specific one. Okay. And then our final factoring one, and David, I'm putting them all kind of together just so that, because it is a common theme that people struggle with, and I want to make sure that I go through that with you. This one over here is one that's, again, kind of tricky, mainly because, sorry about that, my bad. Come on. Oh, hold up. There's always gonna be another mountain. We can do this. It's the climb. Isn't that? I think that's Miley Cyrus, right? I think that is. Okay. So when we put in x in for sine, we have 2x squared plus 3x plus 1. You say, Coach, why do you do that? Well, as I look at this, I see that there are 3 terms. Term 1, term 2, and term 3. A common mistake people take with this problem is they take out a sign, and they can't because there's no sign for all 3 of these values. But what I can do is if I see something that is both squared and just by itself, I could fill in an x with, x in for sine. So what we have now is 2x squared plus 3x plus 1. And so what we're going to look at doing is doing a times c. So we look at, okay, what is a times c? Well, that would be 2 times 1, which would be 2. Okay, so we're going to do that. So it'd be 2 times 1 is 2. I then look to see, okay, what two numbers when added equal my middle value, but when multiplied equal 2? It's the same question if we had x squared plus 2x plus 1, right? What two numbers multiplied equal 1 had to be equal to 2? But because the number in front is 2, we have to multiply a times c, which is the last times the first, to get the number that we multiply to. So this would be both plus 2 and plus 1. So then we put the 2x, because that's what a is, 2x in for both, and we take out something in common. If we take out a 2 here, we're left with x plus 1, and then on the left side, we're left with 2x plus 1. So this would be 2 sine of x plus 1, and then it would also be on the right side, sine of x plus 1. And then since it's equal to 0, this is where we just set both of them equal to 0 here. And we solve it separately, okay? So we say sine of x equals -1. We look on the unit circle, and sine of x, when I subtract 1 and divide by 2, I'd get -1/2. So in all, these would all have plus 2 pi into it, but -1 would end up being 3 pi over 2. Sine of x equals -1/2 would end up being what was that? 7 pi over 6 and 11 pi over 6. And these would all add 2 pi in to it unless it had an interval that was there. Cool. So David, I literally went through most every factoring problem that you'll need to know. If I give one like this, maybe like sine to the 4th of x minus cosine to the 4th of x, that was on the last test. What we'd be looking at there is splitting it up by taking the square root of both and having a plus or minus. So this would be like sine squared x in for both. And then it would be the square root of cosine to the 4th would be cosine squared x. So just make sure that you know how to have both one that's a plus and a minus. I don't think that that's on the test, but I wanted to make sure I hit that that there, okay? All right. I've not seen you dance, but bust out some moves. I will just, when I'm feeling it in class, this next unit, we'll just kind of do a little bit. You know, I got a little bit, I've got a plethora of things, the jive, the salsa. Sometimes I like to go solo freestyle. It's fun. Thank you, David, for hating on my favorite song. Thank you. Devin, hey, that is a very fair answer. Devin, that's a fair answer. How many tickets do I need to turn in to get out of doing the factoring problems? That's a great question. I don't really take tickets. I take more money, which I don't know if I should say since I am on a live podcast, but just being real. Okay, just being real there. I'm completely joking. Please do not give me money tomorrow or Friday. Rosemary, I love that you just said that, by the way. I'm just reading through the comments. Jay, who's Jason? Only listen to Christian music. David, me too. That's just what other people told me. Cool. Yeah. So I didn't really know the songs until some people just told me that. So yeah. You got to chill with the second oh yeah, the SEC jokes. That's pretty funny. Thanks, Coach Jay. I love this salsa. Very good. I'll give you $5 to not take the test. Anna, yes. Fair. How about a $5 gift card? Devin, yeah, that's yeah. Oh my goodness. Oh man. Devin, you gotta, I got something funny that happened. It just reminded me in class. It's pretty good on this. So I went through all these. Do y'all have any other questions that I can go through? I went through quite a few of them, just kind of all together. Please do not miss ones like number 20. There's some problems that if you missed, not that that's okay. We want to try to do the best we can and get all of them right. But there's a couple on them, as you know, on all tests that those are ones that are kind of separate the A's from the B's, maybe. You could still miss them and do very well on the test. But ones like number 20 are ones that I feel like are gimmies, where if I give you something that's the actual formula, understanding that this is sine of u, cosine of v plus cosine of u, sine of v, and understanding that in this context, this is equal to, based off our formula sheet, sine of u plus v. And when I plug this back in, I would get sine of u, which was 140, plus whatever v is, which was 50, which would equal sine of 190. So sine of 190 would end up being what the simplified version was. So I just wanted you to be aware of how I would attack ones like this. Similar to that would be the ones like the tangent of 25. This would be equal to the formula of tangent of u plus v, just seeing that. And then this one would be equal to sine of u plus v. The tough part with this one is identifying the u as pi over 12 and also then identifying the v as pi over 4 and then creating a common denominator, right? So we have the 12 as the common denominator. So we'll multiply top and bottom by 3. And we get pi over 12 plus 3 pi over 12, sine of that. And that would be sine of 4 pi over 12, which we could keep going. So I just keep it rolling, which is sine of pi over 3, which would be 60 degrees. So that would be square root of 3 over 2. So if I can actually solve it, go ahead. And if I can't, kind of like what I did over here, I just leave it as the simplified version of sine of 190 on that one. Cool. Cool beans. Can you go over finding the exact value? Sine of pi over 12. Yeah, that would be a good one. Let's do it. Hey, I hear you, David. I do like my Cole Hans there. Graham, what's up, man? Michigan tickets and I don't take the test. Wow, that's really, really tempting. I would love that. I would love that. Jackson, if I get every answer correct, can I get a 100? I'll tell you what, that's probably the only bet that I have heard so far that's actually a pretty good one. I would take that. I will do that, okay? Rosemary, I do like Cheez-Its. That's probably my favorite smack that I have. Or I actually we call them snoochers in our house. We like snoochers. Yeah, let's do number 5. Let's roll. Hold up. Is this Annie or Anna? It's hard to see because I can't. Do I see the full name? Is it David? You make fun of me? Am I seeing things? I might be seeing things, y'all. My fault. We'll do number 5 and then hold on. Did Devin have one earlier? Sine of pi over 12. Yeah, let's do sine of pi over 12 first. And then we can rock and roll. Cool. Hey, right now I'm looking, my computer needs charged real quick. Hold off just for a second, and then we'll rock and roll from there, okay? Cool. So do this real quick. I'm going to get this charger rolling, and I'll come back to it, all right? Gucci, all right, hold it. Go ahead to sine of pi over 12, and I'm going to go get my charger, and I think it's down in my basement, so I'll go run and get that real quick, and then we'll rock and roll. Hey, as I'm doing this, I am looking right now and just noticed, Annie, I'm sorry about that. I was not even looking at the full name. And I was like, what is going on? And I was like, why is David saying this? Did I mess up? And then I looked closer. My apologies there. I don't know why I said Ann. But we are good to go. And we'll be rocking. All right. Yeah, there you are. Okay. Gotcha. Now I scrolled down. Number 5. And we are rocking. Perfect. No sarcasm, Devin. I love you guys. I really do. Oh, hold on, Devin. I thought that meant that you had a good day. So, man, y'all are roasting me. Y'all are roasting this class. Man, come on now. This is gonna be fun. Take this test. Have a little opportunity that's at our door. I love it. Love it. Hey, in all seriousness, you are here today, so I appreciate you for showing up. I understand that this was this is tough, right? So a lot of stuff on this is difficult. What I would recommend is making sure that you understand the strategies. I keep saying that, but the test and the review have similar sections on it. I'm not saying that they're the exact same problems because they're not, but the strategies are pretty good to where if you were able to attack these and you knew the strategies and you knew the process of them, I feel like you'll do pretty well on this test. And so I hope that encourages, not discourages you. And tomorrow morning, we'll come on in early. Take a look at some problems if you have any more, okay? All right, sweet. So let's do number 21, and then I'm going to go to number 5, like Annie was saying. And we'll go from there, okay? So we're going to multiply by 180 over pi. So we'll put 12 into 180 15 times, and we'll simplify. So we got sine of 15 degrees. And when we look at this, we're looking at sine of 2 angles because 15 is not on the unit circle, right? 2 angles that either add or subtract that equal 15 degrees. And so what we could do is say 45 minus 30. And now what we've got now is we've got this thing of sine of u minus v, which is our formula. And we can simply plug in our formula, which is straight off our formula sheet of sine of u cosine v minus cosine u sine v. And now what we're doing is we're just plugging in u for the first and v for the second. So we've got sine of 45 cosine of 30 minus cosine of 45 sine of 30. There we are. So then the unit circle is what we would use here to state that sine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. And sine of 30 is 1/2. And then we could just distribute, which again, I'll put in yellow down here on the bottom. And so we have square root of 2 times square root of 3 is square root of 6. 2 and 2 make 4. Minus square root of 2 times 1 is square root of 2. 2 and 2 make 4. And I could subtract these because they got a common denominator, CD, which would be square root of 6, minus square root of 2 all over 4. Okay, good stuff. I hope this helped here. Yeah, Jackson, you will get a formula sheet and a unit circle. Okay. All right, Annie, I love that you carved pumpkins, by the way. We just did that this last weekend. That's awesome. And Rosemary, I apologize. Yeah, you usually don't have days off, which I know we've talked about that before. Let's go to number 5. I think Annie had one on number 5 there. And oh, yeah. So, hey, Annie, I'm guessing, and I could be completely off by this. I'm guessing that the question that you have on number 5 is, how do I attack this right here, right? How do I simplify that? Well, one thing that I can tell you is when I take sine squared of whatever is in parentheses here, I could transform this. This is straight off my formula sheet. Your formula sheet says this, though. Pi over 2 minus x equals cosine of x. The problem that a lot of people messed up on the last test was, what do I do when this is squared? Well, it's pretty nice that all you have to do is square the other side. So literally sine squared of all this is equal to cosine squared. So this is equal to cosine squared. Again, I freeze this right side. Well, this is an identity, which is 1. So 1 equals what my answer is on that right side, which is 1. So if it is squared, we can actually we can plug in that same formula and move forward with it. Okay, cool. Sweet. Hey, if you have any last minute questions, go ahead and put that on here. I know it's 9:15. We've gone at it for about 45 minutes. I want to try to help you with something, but I want to pull it up. So do this. If you got any questions, put them on there because I will address those as we wrap it up. But I wanted to see if we had anything else that's there. See if I've got this. I've got something I wanted to pull up for y'all as we're wrapping up. If you have any more. Perfect. I wanted to see, where are you? Lele, why don't you just meet me in the middle? It's a good song too. I like pop music. I don't know if y'all do. I'm not, a little. I feel it. I dig it a little bit. All right, where are you at? I think this is you. Nope, not you. Yep, you. Okay, let me see if I've got. Can't do that one. I don't think that's the one I'm looking for. I just thought about this as I'm wrapping this up here. Okay, I think this is it. All right. As you're, again, throwing those down there, I don't know if there'll be one exactly like that, Rosemary. There might be, specifically with the common denominator part. All I would say is if it becomes really hard, and if I saw one like number 10, I would save that until the very end, in my opinion. So that's what I would do if I were you. So if you're like, Coach, what should I do with that? That's what I would do there. That is what I would do. Right now, I am just kind of coming on this a test that was given in the past, and I usually don't do this, but I'm looking down here. Looking and seeing here, seeing if I could help you out, giving some more of these. Yes. Okay, it's good. All right, I'm going to share something with y'all. I hope this is helpful for you. This is a good example of maybe some other stuff that you could maybe look at and study. And so I'm gonna share this with you. So I didn't see any other questions that were there, unless there were. I don't think I saw any other ones. But I wanted to share this with you for those of you who have stayed on the podcast. And I'd like to just show this to you. These right here are, this is just a practice test from previous years. I will tell you a couple things that won't be on there. That 2x, remember the 2x that follows sign? That 2 will not be on there. You will not have to know that one. So just a heads up there. This for number 12 is one that you'll might be a good one to know. This is off of number 1 off of your review. So might be something just to think about. When you think about number 13, matching up secant squared to tangent, what identity could we put into secant squared to where it matches up to tangent squared to where I could then solve? That's a good one just to kind of bring up. Number 14 was off the review, is actually the exact same one off the review. So just remember that there. Number 15 is one where we're solving. Again, we won't have multiple choice on the test, but that's just a good example there. Number 10 is one we've already kind of discussed. Number 9 will not be on there, but I wanted to just show it to you. Feel free to screenshot these two. I think we went through all of those. Yes, we did. This is a good one too, number 9, about, hey, how do I solve this? Well, I would bring all of them to one side and then factor them. So number 9 might be one that you kind of double check on if you want to bring it in tomorrow morning. Number 8, this is a multiple choice one, which again is, I don't like multiple choice in this situation, but you could kind of verify the identity, how the left side matches up to equal 1. So you could show that there. 7 is another identity one that might be a good one just to kind of show off that. Scrolling up. Number 2, again, another identity. If you were looking for another rep in there, you could kind of get that in. Check that out. Here's another identity, number 7. And again, I'm kind of going all over the place, but this just kind of allows you to pause the screen and get that there and maybe get some help on some of these tomorrow. Here's another example in terms of number 2, identifying what the trig or trying to verify this identity. So I say all that. You could go back in those that area and just kind of copy and go through any example problems. But the big thing is just going through strategies. The strategies are very, very key. And if you say, Coach, tomorrow, come in tomorrow. Coach, I'm really struggling on fill in the blank, right? If you were honest, maybe some of you are actually struggling on a lot of this, which is fair. But I think a lot of times what I've found is that a lot of the struggles occur not necessarily with all these 5 things, but there's maybe one specific area that you struggle on that maybe has bled over to other areas on the test as well. What we want to do is identify that for you as an individual and then help you with giving you problems and having you try to explain it to me tomorrow morning. So if that's something that you would like to do, that would be fantastic. Also note that if you are watching this and you have the test on Friday, unfortunately on Fridays, I usually have a hard time to coming in the mornings because I've got duty on Friday mornings as well. So make sure that you plan accordingly. If you need to come and meet with me at some other point, that's why I do this podcast. So hopefully this will help you out before the test. If you got major questions, I'll have about the first 5 minutes or 10 minutes or so to be able to go through those questions and go from there. I think that is it. Other than that, hey, y'all have a great night. Appreciate y'all. And thanks for your hard work. Love y'all. Bye.